Welcome back to my channel, Geophysics for Everyone. I do hope that you enjoyed the video. Thank you. Today we are going to talk about natural magnetic minerals. This video is a part of video series intended for a fourth-year geophysics courses entitled Capita Selecta in Geophysics or Special Topics in Geophysics at Institut Teknologi Bandung in Bandung, Indonesia. So, what are the natural magnetic minerals? Some minerals have peculiar properties. Not many minerals are magnetic. In nature, the magnetic minerals could be grouped into three groups. That's called the iron titanium oxides, the iron sulfides, as well as the iron hydroxides. By far, the iron titanium oxides are the most important, and members of these groups include magnetite, hematite, as well as maghemite. The minerals that belong to iron sulfides are pyrite and also pyrrhotite, and the mineral that belongs to iron hydroxide is goethite. Let's talk more about the iron titanium oxide. This group of minerals actually could be represented in these ternary diagrams. So as you could see in these ternary diagrams, there's an N member, that is rutile, so this titanium oxide, and then wustite, and then hematite. So the other minerals would be somewhere in these diagrams. The main important thing in this diagram is that there's a tendency that certain group of iron titanium oxide will be grouped together in a particular way. One of them is called the titanomagnetite series. Okay, so this is between ulfospinel and magnetite, and also there's another series that's called titanohematite between ilmenite and hematite. So in a sense, the more titanium that you have in the minerals, then the less magnetic the minerals will be. So the stronger minerals are actually magnetite and hematite. This table shows the magnetic properties of various natural magnetic minerals. As you could see, the properties vary greatly between one mineral to another one. Please note that there is a column that's called Curie temperature. So Curie temperature is a temperature at which the mineral would lose its magnetic properties. And different minerals would have different Curie temperature. And this property is used as a tool to identify minerals actually. There's also the saturation magnetization, GS, and that shows how strong the magnetization will be. As you could see, that magnetite is the strongest natural magnetic mineral. Magnetite also have the highest susceptibility, both in volume and in mass susceptibility. As you could see, these variations in properties are actually very useful in identifying this mineral. Now, the other interesting things about magnetic properties are the magnetic properties are peculiar. Magnetic properties are grain size dependent. It means that if you have grain size with different size, the magnetic property would be a little bit different. Okay? The magnetic properties is also shape dependent. So the shape of the grains would somehow determine some of the magnetic properties. The magnetic properties are also temperature dependent. As mentioned earlier, the magnetic minerals would lose the magnetic properties at Curie temperature. So normally the minerals will be less and less magnetic as you heat them up. Now, when we deal with the natural magnetic minerals, there's some complexity. There's a possibility that within a particular sediments or within particular rocks, they have various minerals, magnetic minerals. So you could have magnetite and hematite in the same rocks, for example. In the natural minerals, Even though you have single mineral, you could have minerals with different grain size and also with different grain shape. So this variation make the identifications of rock it's rather challenging. Okay? Therefore, identification of mineralogy and granulometry or grain size and shape are the main interests in rock magnetic studies. In the next video, we will be talking about rock magnetic research here at ITB. Thank you for watching. I hope you enjoyed the video. I'll see you later. Bye-bye.